Introduction to EM spectrum. Electromagnetic waves are the perpendicular interaction of electric and magnetic fields. Such interaction has a range of variations from frequency to wavelength that compose the electromagnetic spectrum. There are 7 different variations that these waves can follow, starting from longest wavelength to lowest frequency and lowest energy. Radio waves have the longest wavelength and lowest frequency. Then comes microwaves. And no, we don't mean the cooking appliance that heats up your food, but the waves that work inside it. Then comes infrared radiation. At the middle of the electromagnetic spectrum comes visible light, which includes the colors you see now: red, orange, yellow, green, blue, indigo, and violet, as known as Roy G. Biv. Then comes ultraviolet radiation. Then X radiation, or X-rays. Finally, there are gamma rays, classified for their shortest wavelength, highest frequency, and highest energy, not to mention their monstrous effect on Dr. Bruce Banner. Now where were we? Oh yeah, infrared radiation. Infrared radiation lies between microwaves and visible light on the electromagnetic spectrum. Similar to visible light, infrared is composed of divergent wavelengths, as seen in far infrared and near infrared. Far infrared with longer wavelength compromises the sensation of heat. Near infrared with shorter wavelength cannot be detected by human senses, unless you count seeing the TV channel change after sending short infrared waves from your remote control. Although humans cannot detect infrared, pit vipers can. Rather than depending on visible light to hunt, like most predators, this family of snakes utilizes infrared vision to sense and ensnare their warm-blooded prey. Infrared radiation modulates between the wavelength of 750 nanometers to 1 millimeter and the frequency of 300 gigahertz to 405 terahertz. Perhaps the most obvious source of infrared radiation is the sun. However, anything that releases thermal energy, temperature, is also considered a source. Lamps, burning fireplaces, living organisms, and even ice. In 1800, the German astronomer Sir Frederick William Herschel devised an experiment that led to the discovery of infrared radiation. After measuring the temperatures of different visible light, Herschel examined a portion of the electromagnetic spectrum past the hue of red and invisible to the human eye, only to find that it emitted the greatest temperature yet. Herschel's calorific rays have found ever-expanding applications in today's world, from everyday life to industrial advancement. Some USB devices utilize infrared rays. Garage doors have infrared sensors that inform the motors to stop when heat signals is detected. New infrared gas grills have recently become popular for outdoor cooking in fast food restaurants. The military has applied infrared radiation to night vision using infrared goggles and missile technology that allows heat-seeking missiles to track the heat of their targets. The medical field uses infrared radiation to analyze the internal organs of the body, such as in PET scans, which record the activity of glucose in the brain.